Alright, welcome to Chapter 12. So, in Chapter 12, we're going to discuss drive axles, differentials, lockup, limited slip, things like that. So, the first thing I want to dive into is the purpose and function of a differential itself. I'm going to look at this diagram right here in order to explain the purpose and function of a differential. And so, in the diagram, we're illustrating a vehicle that's going through a turn, as indicated by these lines right here. And so one of the issues with a vehicle that has two-wheel drive, okay, a two-wheel drive vehicle has two wheels on the same axle that are being powered by the engine. And one of the issues with that is as we're trying to make a radius, a turn, the inner wheel, its distance that it has to travel is much less than the outer wheel. And so if we look at a vehicle like a go-kart, for example, that has a solid axle, if we didn't have a differential that allows for the difference in speed between these tires, you'd have a scrubbing action that would take place. And so what the differential allows for internally with its components, it allows power transfer to take place while also allowing the two wheels to spin at different speeds. Internally, inside of a differential, we have a bunch of components, gears that we need to go through and discuss. So power typically comes in on a pinion gear. The pinion gear is the gear that's on the other side of the drive shaft that you cannot see when looking at the underside of a vehicle. So the pinion gear drives the ring gear. And so the pinion gear ratio, there's a gear ratio that's exhibited between the pinion gear and the ring gear. And so we typically see that laid out as like a 3.7 to 1 gear ratio or a 410 to 1 gear ratio. It's also called the final gear ratio. And so the final drive gear ratio and the tire size are kind of like the final, after the transmission, it's the final gear reduction that takes place in your drive line. These components in and of themselves are not the differential. The ring gear and the pinion gear are simply the power transfer in to the axle. The unique design of these gears allow for power to be transferred at 90-degree angles. And so the pinion gear itself, if you look at it, it has kind of a funky gear pattern to it. And what that allows for is a walking action to take place off to the side of the ring gear. And so as that pinion gear rotates, it's literally walking itself down on these gears, causing that ring gear to be rotated. This gear set is called a hypoid gear set. This illustration is referring to your pinion gear and ring gear contact. And we're going to talk about like setting up gears at a later point in the chapter, maybe even in the next chapter. Let's take a look. I don't know if it's this one or the next one. Offhand, yeah, it's the next chapter. So your pinion gear and your ring gear have a contact pattern that looks similar to this. In the next chapter, we're going to discuss how to set up a pinion gear and ring gear to make sure that they have proper contact between themselves. But for right now, we're going to have a look at what we call the drive side and the coast side. So the drive side is when you're accelerating the vehicle. You're applying pressure to one side of this gear. There is a backlash on the opposite side. And backlash, all that means is there's a gap, an air gap between those two components. The opposite takes place when you're deaccelerating. So on the next illustration, what they're showing is the coast function. So the first one is drive, when we're pushing up on one side of the gear. So your pinion gear and your ring gear are making contact on one side. Coast is when you're deaccelerating. That's when we have a transfer of power to the other side of the gear. So there's an air gap that moves. That difference between drive and coast is called backlash. Float occurs when we're kind of accelerating, deaccelerating. There's a little bit of power coming in, not a whole lot. We can actually achieve what's called float when we're sitting between the two gears, and there's actually backlash between the drive side and the coast side of your ring gear. Something important to note is some manufacturers, you don't see this on a lot of newer vehicles, but on your maybe mid 90s, early 2000 cars, manufacturers that had anti-lock brakes didn't always monitor individual wheels. They would monitor the entire axle as a whole. And so when you're servicing these differentials, or if you're trying to diagnose an anti-lock brake issue, keep in mind that there is a ring gear, a reluctor wheel, inside of a lot of these older vehicles. And one of the ways you can determine this is if you look on the case itself, you'll see this sensor sticking and protruding outside of the case. And if you look at the driver's side and you look at the passenger side wheel itself, you won't see any wires coming out of there, indicating that the anti-lock brake sensor component is internal inside of the differential. It can make it a trick if you've got an issue. So let's say there was some damage caused, wear and tear, maybe the magnet itself has on the sensor has picked up a bunch of debris. Servicing that sensor, beyond just replacing the sensor itself, servicing the actual ring gear itself is going to require complete disassembly of the differential. You have to get all those gears out in order to service the reluctor wheel on that ring gear. So all pinion gears have two tapered roller bearings, as illustrated in this diagram on page 215, figure 12-13. So the pinion gear itself must be supported. In between, there's a crush sleeve, and we're going to talk about the crush sleeve when we get into the servicing chapter, which is the next chapter. So there's a bearing that sits on the front side and the bearing that sits on the inboard side of that gear setup. Likewise, the carrier itself is what we call this entire ring gear and differential components. The carrier itself is also supported on a bearing on the driver's side and the passenger side. The differential components themselves are the gears that allow a walking action to take place and power to be transferred at different RPMs from the driver's side axle to the rear side axle, driver's side axle to the passenger side axle. So one of the common issues with differentials is we can get a scenario where we end up with one wheel getting 100% of the engine's power and the other wheel sitting completely still. If you maybe have been around some people that have done burnouts before, you may have seen what's called a one-tire fire. That's where one tire breaks loose and all that power is able to transfer to the wheel that is able to spin. That's a major drawback to a differential's design. So a differential is great. We call that an open differential. So an open differential is great on dry surfaces. When we don't have like a vehicle stuck off on some like one side of the road, one tire sitting on some ice, and we're trying to accelerate that vehicle. An open differential does not have the ability to transfer power to the wheel that actually has traction. It's going to transfer the power to the tire that is easiest to spin. And so manufacturers have come up with a variety of different techniques in order to allow power to be transferred in a case where maybe you're on ice, right? So you've got one tire that's able to spin very quickly and the other tire is just sitting there on the pavement maybe, not able to do anything, so the vehicle is stranded on the side of the road. And so what manufacturers have come up with are locking mechanisms and limited slip mechanisms that monitor, in a sense, they monitor overall axle speed difference, and so they're able to determine when a threshold has been reached where maybe the outside tire is now spinning at 1,000 RPMs, the inside is spinning at 0. There's a difference that's great enough between the two wheels that it'll go ahead and lock both the driver's side and the passenger side axle together in order to allow power transfer to happen evenly on both wheels. So limited slip terminology. Limited slips that's a generic name, as the book even states. The componentry that's utilized in a limited slip, from a Ford product to a Japanese, Honda, for example, the components they use are not necessarily going to look the same. Limited slip is strictly just a terminology that's used to reference an axle that has the ability to lock up in the case of, as previously stated. So on page 220, the book goes through a few of the different designs that are out there for limited slip or lockup type differentials. Some limited slip differentials use a cone and clutch design. Some manufacturers use what's called an Eaton locker differential. Some manufacturers use self-applying clutches. Some use viscous couplings. Some use, even the book doesn't talk about all of them. Some use torsion. Some use hydraulics that are applied to these mechanisms. So I want to talk about page 222 and page 223 and kind of just give you a summary of what's going on here. You guys can read through this and look at individual components and different manufacturers and how they go through this. But if we take a look at page 222 and page 223, what we're illustrating here are the various types of mechanisms that are used by manufacturers in order to lock the driver's side and passenger side axle together. Some manufacturers use mechanical componentry. And so what they'll do is they'll literally have like centrifugal weights that maybe apply when the wheel speed is too great. There's too great variation between wheel speed. They'll use a mechanical actuator of some kind that centrifugally locks the two halves together. Some manufacturers use what's called viscous coupling. What viscous coupling is, it's literally a fluid inside of maybe a piston, and as the temperature increases due to the slip, the viscosity of the fluid increases and applies pressure against those clutch plates, which locks the two halves together. Once you're driving back down the road again, when the vehicle speed is when the axle speed is more closely matched, the temperature of that fluid, since it's not slipping anymore, will start to come down. It'll start to thin out, and then you'll unlock those two axles. Same thing with your mechanical style. When an RPM difference is achieved that's great enough, centrifugally, you'll have mechanical components that lock the two axle halves together, but then when you're driving down the highway and the axle speeds start to match themselves again, start to match each other again, those mechanical components that are centrifugally activated will unlock. And so you'll have a scenario where the vehicle automatically is locking up and then unlocking. These are the dumb versions. Modern cars are going to computer controlled lockup componentry. And so most manufacturers nowadays, that especially on your all-wheel drive vehicles, what they're doing is they're actually monitoring wheel speed, and they're referencing the wheel speed in a computer, and that computer is now deciding if the wheel speed is too great. So there's a variety of ways manufacturers can design these components, and it's important as a technician to understand what you're working on, because what customers are on these old styles, they might not even know that they have an issue with their lockup in their differential, and so they might be driving around for 100,000 miles and never realize that they have a limited slip component, a clutch plate that's burnt up, or maybe a centrifugal locking mechanism that's broken. And they just know that their car doesn't perform very well on slippery surfaces, and so they try to stay away from the slippery surfaces. Well, on your more modern vehicles, they have sensing circuits that give feedback to a computer, and so what will happen is you'll end up getting, like, not a check engine light because that's emissions related, but you'll get some sort of service monitoring light that'll come on and be illuminated. And so the customer will bring the vehicle to your shop because this light's on the dash, and you'll scan the vehicle and you'll come up with codes that might be bizarre to you the first time you see it, but they'll be referencing wheel speed issues and or lockup component issues internal. So you'll get codes that point to maybe a hydraulic circuit, or a code that points to like a special kind of solenoid or something really bizarre. And so that's more on your all-wheel drive cars, though. That's more on your all-wheel drive performance type vehicles that are utilizing that electronic type setup.